Today's lesson 5.4, we will begin to look at logarithms and the logarithmic functions. I've broken up this lesson into two sections, but by the end of this lesson 2, you will be able to investigate logarithmic functions and relate them to exponential functions. But for today's lesson, we'll be looking at writing exponential expression in log forms and to evaluate logarithm. The key concept is that the logarithmic function is the inverse of the exponential function, and the characteristics of the graphs of logarithmic functions and the exponential functions are related. I'll explain what that means in a minute. And the definition for a log function is y is equal to log base to the x, log b to the x. And the exponential function, as we learned from the 3 previous lessons, is y is equal to b to the x. The domain is x is greater than 0. An overview of the key concept, meaning that the exponential and log functions are related. And this is found in your exponential log booklet on page 10. And the log function, which is one on the right here, it is the inverse of the exponential function. You have y equal 3 to the x and y equal to log 3 to the x. I'll explain how we write these expressions. That's our goal today, how we write y equals 3 to the x to y equal to log 3 to the x. Notice these log function is the inverse. And just to recap, if you have an exponential function, the graph has a y-intercept 1. Now, the log function, the graph has an x-intercept. Notice this is a y-intercept for exponential function, but log function is an x-intercept. There's no x-intercept in a standard exponential function, y equals 3 to the x. For this function, y equals 3 to the x, there's no x-intercept. But there is x-intercept for log 3 to the x, the inverse of it. There's no y-intercept. There's an asymptote here in the log function. While the asymptote for the exponential function is a y equals 0, because the graph never touches the x-axis. This graph has no y-intercept, and now the domain is from 0 to infinity, while the domain for the exponential function is all the real numbers, negative infinity to infinity. The range for the log function is all the real numbers, negative infinity to positive infinity, while the range for y equals 3 to the x is y is greater than 0. Now that's for 3 to the x. So they're related. So this is what we'll be completing by the end of lesson 2, which will be done in the next lesson. In essence, if we were to write the log function exponential function, this is our exponential function y equal to a b to the x. The log function is y equals a log b to the x, where a is not equal to 0, b is greater than 0, and b is not equal to 1. Okay. Just to recap, now let's look at what is a brief introduction to log. In simplest form, a log answers the question, how many of one number do we multiply to get another number? And in this example here, how many 2's do we multiply to get 8? There are 3 2's. is 2 times 2 times 2 equal 8. So we had to multiply 3 of the 2's to get 8. So the log of the logarithm is 3. So the logarithm of 8 is 3. And how do we write that? We write the number 2 as if we need to multiply to get 8 is 3. So 2 log 2. What do we get? If we multiply this, our exponent would be this. If we look at the relationship, this would be 2 to the power 8, 2 to the power 3, sorry. 2 to the power 3 is equal to 8. This is our base. We'll learn that later if you haven't known it. That should be the base. So log base 2 to 8 is 3. In other words, how many times do I multiply 2 to give me by itself, 2 multiplied by itself, to give me 8? And that'll be 2 times 2 times 2. So essentially, these two things are the same. Right. What you have over here is 3. Here's log 2 to the 8. So here we have log base 2 to the 8 gives us 3. And the way we say that is the log of 8 with base 2 is 3. So log of 8 to the base 2 is 3. Or log base 2 of 8 is 3. Or the base 2 log of 8 is 3. So either one of these three ways we could name it. So we can say, for example, the log of 8 with base 2 is 3. Log base 2 of 8 is 3. So I'll be using them interchangeably. In this case here, notice we're dealing with 3 numbers. The base, the number we are multiplying. In this case, 2 as the example. So we have the log 2, so our base is 3. Okay, missed it. Okay. Repeat. Notice we are dealing with 3 numbers. The base, so this would be our base. So log 2. So this refers to the base. The number we are multiplying. So this is the number we are multiplying. It would be 2 times 2 times 2. Now this is how many times you're multiplying, 3 times. So how often we multiply it is called the logarithm. Let's look at another example here. What is log 5 to 625? We're asking how many 5s do we need to multiply to be multiplied to get 625? So we have 5 times 5 times 5 times 5. So you multiply 5 by itself 4 times to give us 625. So the log of base 5 to 625 is 4. If you were to write it exponential now, we write that as 5 to the power 4, 625. They are related. What is log base 2 to 64? How many times do I multiply 2 by itself that gives me 64? And maybe 6. 2 times 2 times 2. That is log. Log is asking how many 2's do we need to multiply to get a number. Exponential now saying how many times to use that number in a multiplication. So let's look at this here. Example, these 2 exponents is 3. In this example, 2 to the power of 3 is 2 is used 3 times to get 8. So you have 2 to 1. So we have 2 to the power of 3 equals 8. And we can transfer that into a log, because this is our exponent. Right? Our exponent now is our log. So this is our exponent here, that will be our log. So log 2, base 2 of 8 is equal to 3. So we say the log is 3 of base 2 of 8. The log tells us what exponent is. In this example here, if we know log 2 to the 8, it tells us this is their exponent. And we can put them all in nutshells. You have ax equal y, or you can write y is equal to a to the x. This is our exponent. Remember, this is equivalent to the log. This is our base. So that's why we can write log a to the y equal to our exponent. What is log 10, base 10 to 100? Now, that will be, how many times do I multiply 10 by itself to give me 100? That will be 2. Now, this is my exponent now. So that's why it'd be 10 to the power 2 equals 100. Let's look at another example, log 3 to the 81. How many times do I multiply 3 by itself to give me 81? The answer is 4. So we have 3 times 3, 9 times 3, 27 times 3 is 81. So 3 to the power of 4 is equal to 81. So now this is my log. So exponent of 4 need to make 3 in 81, and it's read as log 3 to the 81 equal 4. That's a simplified version of what log is. Now let's go back to comparing them. So we mentioned earlier that log is used to describe the inverse of a power or an exponent. 10 to the power x is equal to log 10 to the x, which is a base 10. I will talk a little bit later on more about base 10. So here we're comparing. We have y equals 10 to the power x, and we change that to a log form. Y is equal to log 10 to the x. Notice it's the inverse of each other. If we were to look at the coordinates now for each one, we find for the y equal to 10 to the x, when x is 1, y is increasing by this multiple of 10 here. So x is 0, y is 1, x is 1, y is 10, x is 2, y is 100. If you look at y equal to the inverse of this exponential, when x is 1, y is 0. When x is 10, y is 1. When x is 100, y is 2. So we know this is actually not increasing by a multiple of 10, but it is decreasing by a multiple of 10. So log 10 to the 100 equals 2 because 10 to the power of 2 is equal to 100. Means that 10 raised to the power of 2 to get 100. So what we did earlier, so we'll be using that fact. So putting all of that together, the log of a number is an exponent. This is here. Log b to the c is the power to which b is raised to get c. So the base of a log is the same as the base of the power. So here is the base of the power and the base of the log. So these are the same. The exponent of the exponential is the log, as we mentioned before. So we'll be using this fact here. Now we know how to change exponential to log and log to exponential. Let's look at a few examples here. Write expression in different forms. We are asked to write each exponential expression as a log expression. So we're given exponential, we need to change into the form of a log. So notice here, the log base, the base is 2 here. So this is our base. So we're going to rewrite here. This is our base. And c is equal to exponent. Okay, so if you were to rewrite that, so this is our base, this is our exponent, this is our c. So we say log, our base is 2. This is our c, okay, is equal to our exponent of 5. Here the base is 3. So here we have the base is 3. So base is 3. The exponent is negative 4. So go back to here. This is our base, and this is our exponent right here. See, log base 3 to the c is 1 over 801, and this is our exponent, negative 4. Let's look at the next question. The base is 7. Our exponent is 0. And our c is 1, so we have log b to the c is equal to a, which is our, so we have log 7, 1, going to equal to 0. In other words, 7 to the power of 0 equal 1. Now we asked to do the reverse in this case here. Just remember, we are using this as our fact. We have, just rewrite. So we're changing this. We're going to have log b to the c is equal to a. And we can change that to b to the a is equal to c. So we're changing into an exponential expression. This is our base. So base equals 3. Our exponent would be 4. We can write it as 3 to the power 4 equal 81. The next base is equal to 5. Our exponent, maybe if you were to help yourself here, exponent is 3. So we end up with 5 to the power 3 equals 125. The final one, we have log 6 as your base. So we have base is 6. Exponent equals 0. So this will give us 6 to the power 0 equals 1. Now, what happens when we have logarithm other than base 10? Here we have an example where we have log 2 to 2 to 2/3. Now, we can rewrite this as, it means is the power to the 2 is raised to get 2 to the power 3, which is 3. So log 2 to 2/3, 2 to the power 3 is equal to 3. Now, let me explain that what I mean. So we have log 2. Now, 2 to the power 3 now 2 to the power 3 can be written as 8. So if we replace 2 to the power 3 with 8, let me put 8 here. Now, what would that be? Well, how many times we multiply 2 to give us 8? The answer would be 3. So that's why we could say that to which power 2 is raised to get 8, and it will be this exponent here, which is 3. So once we have a form where we have the base and the power to which is raised is the same, the exponent here would be your log. Here's another example. Log 4 to 4/6 is equal to 6. Right. Is the power to which 4 is raised to get 4/6. What power, how many times do I multiply 4 by itself to give me 4 to the power 6? The answer is 6. So we can conclude that log b, right, is the power to which b is raised to the power n is equal to n. So they are inverses. So let's use that too. So I'm going to use this fact here to evaluate these logs here. So I'll write that in the corner here so you will we can compare them as we go through them. So we have log e to the b n. The answer is n, is log n. So how do we go about doing this? First thing, we want it in the form, we want to find an answer, evaluate it, find what this means. This is equal to. First thing, we need to, now remember, we want 3. We want to write 729 now as a power of 3. So step 1, write 729 as a power of 3. So 3 to what power equals 729? And that will be 3 to the power 6. So I'll replace this now. So log 3. 729, I'll replace that with 3 to the power 6. And using our formula, we realize is equal to 6. Now you could have completed a long way by finding how many times 3 can go into 729. So how many times you can multiply 3 by itself to give you 729, and the answer would be 6. Either way, you could completed it, but anytime you're given a form of log of this, the answer is immediately the exponent here. That's what this is telling us. So the answer here will be 6. Now, the next thing here, we write 32 as the power of 4. So we can write that as, so 2 to the power of 5. Now, here's a challenge. To raise the power of 4, you cannot do it by itself. So if you were to do this, we can have a power of 2. So we can say we cannot have a power of 4 here, because 4 times 4 is 16. 4 to the power of 3 is 64. It will not work. So we try 2 first. We have 2 to the power of 5 is 32. But here's the thing. We can write 2 as a square root of 4. So 2 can be written as a square root of 4. Okay, so I'm going to replace 2 here. By the way, this should be negative 5 here. Okay. But so we have square root of 4, right, to the power negative 5. Okay. So now this is, now we can write it as exponent using our exponent rules, which is 4 to negative 5 over 2. Because remember, this is 2 here. I'm writing it back as exponent. So all of this here is 4 to the negative 5 over 2. So I can write as log 4. Now, this becomes 4 negative 5 over 2. And that's my answer, negative So log is equal to -5/2. This is a bit tricky one because you cannot find 32. You cannot find 32 as a power of 4 directly. You have to do it indirectly. The tricky question was one, do you know it? It's another way of writing 4, and you have to be careful. 4 can be written as a square root of 4. Sorry, 2 can be written as a square root of 4. And that's what you did here. 2 can be written as a square root of 4. The last one, now we need to write this as a power of 2. So look at your base. That will tell you what you have to change to write it as a power of. So you need to write 4 as a power of 2. So we have 3, 4 is equal to 4 to the 1/3. Now I need to change, this can be written as 2 to the power 2 to the 1/3. I'm changing 4 into 2 to the power 1/3. So now all of this here can be changed to 2/3. Now 2 times 1/3 is 2/3, so we write it as log 2 to the 2 2/3. Answer is 2/3. So your task is to work on check your understanding 1 on page 377, and check your understanding number 2 on page 378. So to summarize, today we learned of a logarithm, and we can write the expression in a different form. We can change a log into an exponential function. We see that b to the power a equals c is equal to log b to the c equals a. Then we looked at logarithm other than base 10. And in this case here, we said that log b to the n is equal to n. Oops, here we go. And we learned how to evaluate logarithm and also to change the form of the logarithm. Our next lesson will be looking at log function and sketching log function.